This lesson is on how to solve for x using parallel lines and transversal. So let's go over some definitions. These definitions were defined for us in the last lesson where we did parallel lines with transversal. And so if you need to go back and look at that video, go ahead and do so before you continue on with this, because this is now using the application of knowing our definitions, because this is now the application of knowing the definitions to solve for x. So we went over the definition of supplementary where we said two angles will add up to 180. Vertical angles are when the angles are diagonal from each other and they're equal to the same number. So it could be vertically this way as well. Corresponding angles was when we take the transverse line right here and we cut it up. We would take all of these angles and layer it on top of the first line. So then 1 would correspond with 5, 2 would correspond with 6, 3 would correspond with 7, and then 4 would correspond with 8. We also mentioned about alternate interior angles, which mentions just the angles that are inside the two parallel lines. And so we had said that it is the opposite of the transverse that the angles are the same. So for example, 4 and 5, these are diagonally the same. And then 3 and 6 is exactly the same as well. And the fifth definition we went over is the alternate exterior angles, which is the angles on the outside of the parallel line. So 1 and 2, and then 7 and 8. So similar to the interior angles, the alternate from the transverse are the ones that are the same. So 2 and angle 7 is the same, and then angle 1 and angle 8 is the same as well. I also wanted to use this formatting when I'm solving. It's not a rule in mathematics, but it's nice when you have numbers on the angles, so that way when you describe it and write it up and explain it, it's easier to have a common angles that we're speaking of. So that's what I'm going to use for this lesson. So let's look at example 1. I have is 9x plus 11 and then 10x plus 5. So let's go ahead and layer our numbers onto this. So then we're going to assume this 9x plus 1 is angle 1 right here. And then we have this angle 2, 3, 4. This is angle 5 right here. Angle 6, angle 7, and angle 8. So going back to now are the definitions. So which of those definitions will I start with? And this is important because if you don't know which definition you're going to use, you don't know how to start this problem. So for example, will I use the supplementary definition to solve for this? Well, if I had 9x plus 11 and then this 10x plus 5 was where angle 2 is, then I can say yes, I can set those problem up as a supplementary problem and solve for it. Or if this 10x plus 5 was where angle 3 is, I can use that as my supplementary definition. But since it's not that, I cannot use that. Number 2 says vertical angles. So I cannot use that either because vertical angle says their angles diagonal from each other are the same. So the 9x plus 11 would have to be the same as the angle 4. And so if this 10x plus 5 was where angle 4 was, then we could say we would use the vertical angle definition. So we can't use that. Number 3 is corresponding angles, which says that if we cut up the transverse right here and take all of these 4 angles, layer it on top of the first line, then they will be equal to each other. And so, yes, this definition is definitely what we're going to use because then we could see that 9x plus 11 is equal to the 10x plus 5, since if I layer this on top of it, they're going to be corresponding to each other. So let's go ahead and start solving for this. So when I set this up, I'm going to have is 9x plus 11 equals 10x plus 5, because as we mentioned, this angle, when I layered this on top of this, is exactly the same. So when we have something that is same, they're equal to each other right here. So now this is the algebra. So we begin by isolating all the x's together and all the numbers together. So I can see I have a 9x right here and I have a 10x right here. Since 10x is bigger, I'm going to go ahead and bring the 9x over to this side of the equal sign. And then because all my x's would now become on the right-hand side of the equal sign, I'm going to have to get rid of 5. So 5 will have to join the 11 on the other side of the equal sign. So I'm going to show that work right there. So 9x was brought over on the other side of the equal sign by doing a subtraction. And the reason being is because right now this was a positive 9 right here. So anything that moves across the equal sign will have to change the sign from positive to negative or negative to positive. And then this right here was a 5 right here. So since it's a positive 5, when it crosses over the equal sign right here, it becomes a negative 5 instead. So now let's go ahead and simplify this. 11 minus 5 will give us 6, and 10 minus 9 will give us 1, so x equals 6. Now if you stop right here, you're not going to get the answer correct, because what we're looking for is what is the angle 1 right here, and what is also angle number 5. So we have to now take our angle 1, the 9x plus 11, and substitute in x equals 6 into this equation right here. So it's going to look something like this. So I have is 9 times the 6 plus 11. If we simplify that, it becomes angle 1 is 54 plus 11. And if we add those together, it becomes angle 1 is equal to 65 degrees. Now, the second one, which was angle 5, is also equal to 65 by the corresponding angle definition. We said if this angle right here is on top of this right here, and they're equal to each other, that's what we also wrote up here, then if I find one side of the angle, the other side of the angle will be exactly the same. Okay, now let's move on to example 2. So here's my problem right here. So let's go ahead and put our numbers to the angles. And so what definition would I use to solve for this? So would I use supplementary? I can't use supplementary because 60 is here, and then the negative 5 plus 13x is here, so they're not next to each other. So that's out of the picture. What about vertical angles? Can't use vertical angles because they would have to be diagonal from each other, so that doesn't work. What about corresponding angles? We could use corresponding angles because then we could go ahead and cut this out, layer it on top of here, so then this negative 5 plus 13x would become angle 1, and then from there we can use the vertical angle rule. So we would actually use two rules for this. Or we can use as number 4 the alternate interior angles, which says that the angles inside of the two parallel lines, if they're the opposite from the transverse, that they're equal to each other. So this 60 is equal to this part right here. So this has to come out to 60 degrees as well. But what is x? So that's what we need to solve for as well. So let's go ahead and solve for that. So I set up my equation as negative 5 plus 13x is equal to 60, because as we mentioned right here before, the alternate interior angle definition says that this 60 is also 60 right here. So we're going to set it equal to 60 right here. Okay, now we're solving for x. So it looks like 13 is the only one that has an x, so we're going to have to bring the 5 over to the other side of the equal sign where 60 is. And we're going to go ahead and add to the 5 because right now it's a negative 5 right here. So if we simplify that, that becomes 13x is equal to 65. And then we need to isolate x by itself, so we're going to divide the 13 out on both sides, and x is equal to 5. Now if I substitute this 5 back into this equation for angle 5, I should get 60. So let's go ahead and see if it comes out to that. So I have is negative 5 plus 13x. If I go ahead and substitute my 5 from here into here, we're going to get 13 times 5 is equal to 65. And then if we add 65 to the negative 5, we're going to get 60. So that works. Okay, example 3. Now let's go ahead and number our angles. Now, which definition fits for this? So it's not supplementary. I can tell you that right now because they're not next to each other. It can't be vertical angles either because they would have to be diagonal from each other. Corresponding, again, it could be corresponding, but then we would have to take from corresponding to supplementary. The alternate interior angles, we can use that as well. But then from alternate interior angles, then we would do supplementary. alternate exterior angles, that wouldn't apply for this one. So we can either start with number 3 and number 4, one of those, and then it's going to end up to do supplementary as well. So in this case, I'm going to go ahead and choose the alternate interior angles. So which says that if I have 69 degrees here, that is going to be exactly the same on this side where angle 5 is. So 5 comes out to 69 degrees. Then I can use the supplementary right here because then together these two angles should come out to 180. Okay, so let's go ahead and set that up. So I have my 69 degrees right here, which is the angle 5, plus then the second angle right here, which is the 12x plus 15. I'm going to keep it in parentheses so that I know that all of this is together as one angle. And then we're going to set it equal to 180 because we're using the supplementary definition. So now after this also helps is to see if there is a negative sign right here, because if there's a negative sign, we definitely have to distribute the negative inside the parentheses. But since it's positive, we do not need to distribute it. So I'm going to go ahead now and drop my parentheses. And so from here, now let's go ahead and sort it out. So it looks like 12x is the only one that has an x. And so that means that's going to stay on this side of the equal sign. So 69 and 15 will have to come onto the other side of the equal sign and join the 180. So if I bring the 69 over, it becomes a negative because it was a positive currently. And so moving it over to the other side of the equal sign, change the sign. Same thing with 15 was a positive 15. And when we bring it over to the other side of the equal sign, becomes a negative 15. Okay, if we simplify that further, it becomes 12x is equal to 96. And if we divide both sides by 12, we're going to get x equals 8. So going back to now solving for this angle 6 right here. So angle 6 was that 12x plus 15. If we substitute our x with 8, we're going to get 12 times 8 plus 15, which gives us 96 plus 15. So angle 6 is equal to 111 degrees. Okay, last example, example 4. I have a 16x plus 2 and then 4x plus 1. So this is definitely going to become the supplementary. So I'm not going to even label the angles for this one. So we're going to go ahead and set up as our supplementary. So from here we have is the 16x plus 2 plus the 43x plus 1 is equal to 180. Now I'm going to go ahead and drop my parentheses and then sort them out. So it looks like I have two of the x's. I have the 16x and the 43x on this side, on the left side of the equal sign. So we're going to have to bring the 2 and the 1 to join the 180. So let's go ahead and do that. So I'm going to subtract 2 and then subtract 1. So that's this part right here. So now let's go ahead and simplify that. So 16x plus 43x gives us 59x. 180 minus 2 minus 1 gives us 177. So we divide both sides by 59 and x equals 3. So now let's go back and solve for the angles. So on the first angle, 16x plus 2, we substitute our 3 into the x, and we get 48 plus 2, and angle 1 is equal to 50 degrees. Next one, on angle 2, we have 43x plus 1. We substitute x equals 3 again, and then we get angle 2 is equal to 130 degrees. And to check it, just to make sure, angle 2 and angle 1 together, when you add them up, should come out to 180 degrees. So this is the lesson that you'll be doing, is just going over the definitions, figuring out where do you start, and then start solving for this.